Hello everyone. Welcome to the another lecture of haloalkenes and haloarenes. Myself Suman Singh. So in the last class, as we have, if you have seen seen the video, you can find that in the last class we have discussed E1 and E2 mechanisms, or E1 and E2 reactions, right? So now from today we will see the preparation, okay, of haloalkenes. So when we talk about the preparation of haloalkenes, we will see first from alkene. Okay, we will see first from alkene. So when we talk about the alkene, so as you can see, it is also written here: alkene react with halogen such as Cl2 or Br2 in presence of sunlight at the ordinary temperature, or by heating at 400 to 500 degrees Celsius, or heating in presence of free radical initiator such as peroxide to give Rx. Okay, as you can see, suppose this is our R, okay, and this is our H, and if we are using here this one halogen here, so what we will get, we will get R and X, right? So here you can see this sigma bond is again changing into a sigma bond. Okay, now next, the reactivity. When we see the reactivity of halogen, so the reactivity of halogen decreases in the order, it will be F2, after that Cl2 and Br2 and I2. Okay, so we will see what will happen here. So this process is just a chain process, okay, and the direct halogenation proceed through a free radical mechanism. Okay, so this process, whatever the process is there from alkene to prepare and the haloalkenes from alkene, this is just like a chain process, and the direct halogenation proceed through a free radical mechanism. We will see the example also. Okay, and this is not a suitable laboratory method, since polyhydrogen derivatives are formed along with the monohalogen derivative. That is why it is not a suitable to laboratory method. Okay, so some of the example, as you can see, we will see after that, we will see one by one. So as you can see the example, suppose we have given this example, okay, CS4, for example, chlorination of methane. When we do the chlorination of methane, it will give four product. As you can see, 1 2 3 and 4. What is happening? CH4 is changing into CS3 Cl, after that again CS2Cl, after that CHCl3, and after that CCl4. Okay, as you can see, it is a very simple process. I hope you are understanding how it is happening, right? So when we talk about the mechanism or the mechanism, so mechanism will be in basically three steps. One will be the initiating step, another one will be the propagating step, and number third will be the terminating step. Okay, so one by one we will see what is happening here. So first of all, in the first process, what will happen, in the initiation step, the reaction is initiated by the breaking of chlorine molecules into a chlorine free radical in presence of UV light. Just like this Cl2, it will be brought in presence of UV rays, okay, H mu, to give chlorine free radical like this. Okay, this one plus this one, this is the first step. Okay, this is also called chain initiating step. Okay, now in the next step, what will happen, this will be the propagating step. Okay, so in the propagating step, it will, what is happening here, you can see the chlorine free radical attack the methane molecule. Okay, this Cl chlorine free radical is about substituent. Okay, as you can see here, what it is happening here, I will write here. Suppose we have CH4, okay, and this CH4 will, this chlorine free radical will attack to this. Okay, like this, it will attack to this, and it will form what here, CH3 plus HCl. Okay, HCl it will form. This is also called a chain propagating step. Okay, now again, what will happen after that, always remember that each methyl free radical, whatever the methyl free radical is there, in turns, what will happen, react with the chlorine molecules to form methyl chloride. Okay, and at the same time, this chlorine free radical is produced. Okay, as you can see here, this methyl free radical, what is happening here, it is just again it is reacting with this chlorine. Okay, and when it is reacting, it is forming what, methyl chloride, as you can see here, and chlorine. Okay, and this is also called a chain propagation. Okay, now next is what, the chlorine free radical, what it will do, the chlorine free radical react with the fresh methane again molecule, as in the next step of methyl chloride, and the process may extend further till all the replacement hydrogen atom in the methane have been substituted by the chlorine atom. Okay, so it will be continued, it will not stop. Okay, and in the same time the chain, this chlorine free radical will react with the fresh methane, and after that again this process will continue, and again in the next step also this chlorine free radical again it will react with the fresh methane molecule. Okay, now so this was what propagating step. Now next is what chain termination step, or we can say the terminating step. So what is happening in this terminating step, we will see that the chain reaction is terminated when any two free radical, with any two free radical, as you can see Cl, as you can see, no need to write, as here you can see what is happening. This one Cl free radical Cl is just breaking Cl2, and here CS3 CS3, this is methyl free radical, and here this is chlorine free radical, it will form in methyl chloride, as you can see here, and this one is reacting to form CS3 and CS3. Okay, so always remember that direct iodination, okay, direct iodination is not possible, as the reaction is very slow. Okay, and reversible and endothermic. Okay, since the iodination is not possible, because as the reaction is very slow, whatever the reaction will be carried out with this iodinations, the reaction will be very slow. Okay, and reversible and as well as endothermic. Okay, so that is why by it is done by heating alkene with I2 in presence of oxidizing agent. Okay, so that is why what is happening, since direct iodination is not possible, so what we are doing in play to do the iodination, what we are doing, we are just heating the alkene, okay, with I2 in presence of some oxidizing agent, just like as you can see here HNO3 and HOI, like this oxidizing agent given, right? So HGO, like this oxidizing agent, in presence of this oxidizing agent we are doing iodination. Okay, because iodination is carried out in the presence of this only. Okay, so these are some of the example through which iodination is carried out. As you can see here, CH4 plus I2 will give CH3I plus HI, and after that again 5HI, as you can see 5HI plus HiO3 will give 3I2 plus 3H2O, and here also 2HI plus 2HNO3 will give I2 2H2 or 2NO2. Again from HGO it has been seen here 2HI plus HGO will give HgI2 plus H2O. So as you can see, what I mean to say that direct iodination is not possible. Okay, now so since direct iodination is not possible, so what we are doing, we are using here an oxidizing agent. Okay, and that oxidizing agent, as you can see, HIO H3O and all this. Okay, now next is fluorination. Okay, so when we talk about the fluorination of alkene is highly endothermic, okay, or explosive, hence it is not been carried out under the ordinary condition, because direct when we do fluorination of alkene is very dangerous. Okay, since it is highly exothermic and explosive. Okay, that is why we are not using the fluorination of alkene. Okay, and next is what, in case of higher alkene, if we are using, if there is any higher alkene, in case of higher alkene, as you can see, even in monohalogen, okay, it gives a mixture of all possible isomeric haloalkanes. Okay, indicating the replacement of all type of possible hydrogen atom present in the given alkene. Okay, so in case of higher alkane, this thing will happen. Okay, now when we talk about the monohalogen, so monohalogen does not depend upon the type of carbon atom. Okay, it will not depend upon the type of carbon atom present in the alkane, but it will depend on the type of replaceable hydrogen atom. Okay, it will not depend upon the type of carbon atom, but it will depend on the type of what type of replaceable hydrogen atom in the given structure. Okay, so what we can say, the relative amount of isomeric haloalkane depend upon the nature of the halogen and the number type of hydrogen. Okay, as you can see here, it will depend on 1 degree, 2 degree and 3 degree being substituted. Okay, and when we see the ease of substitution is of hydrogen will generally follow this trend. 3 degree will be more stable than 2 degree and then 1 degree. Okay, as you can see, I hope you are understanding this. Okay, so As you can see, when we are talking here bromine, when we are taking here bromine, so we are getting two product, okay, as you can see. And if we are taking here Cl2, in this we are getting four product, 1 2 3 and 4 product, okay, as you can see here. Now when we talk about the stability, so always remember that when we talk about the stability, this benzylic or allylic, okay, benzylic or allylic, here you can see benzylic or allylic will be more stable than 3 degree, after the 2 degree and 1 degree, and this will be more stable than CH4 after that vinylic and arylic, okay. Now chlorination of an alkene, which is CH4 and above, give a mixture of DNL optical isomer, as you can see here, okay. Now I hope you have understood this up to this, okay. Now next we will see allylic substitution. When we talk about the allylic substitution, so when alkene is heated with Cl2 or Br2 at high temperature, the hydrogen of the allylic carbon is substituted with the halogen atom without breaking the double bond to form allylic halide. Means what is happening here, you can see it is very clearly, it is written here, whenever this alkene will be heated with this Cl2 or Br2 at high temperature, okay, at high temperature suppose, then what will happen, the hydrogen in the allylic carbon, as you can see, the hydrogen in the allylic carbon, so the hydrogen in the allylic carbon is substituted with the halogen atom, okay, without breaking the double bond to form allylic halide. As you can see, double bond is not breaking, right, it is same as it is, right, as you can see here. If you want to, I can give you, you can write also like this. Suppose this is CS3, right, this one, this CS3 is just looking at CS2 and H, okay, suppose here H. After that, there, let me write it clearly. It is happening like this. Suppose we have CH2 and here it is one hydrogen, okay, and after that this one is double bond CH, okay, sorry, single bond CH, single bond CH, okay, and after that again CH2. So what will happen, this Cl2, when this Cl2 will come, this Cl2 one will be this Cl2, this Cl2, what it will do, it will react with this hydrogen, okay, and it will form like this, as you can see, Cl CH2, okay, after a single bond CH, double bond CH2, okay. I hope you have understood this, and you will come, Cl will come out here. So what we can say, this allylic substitution can be carried out by heating the alkane with SOCl2 at 200 degrees Celsius in presence of light and trace of organic peroxide, okay, as you can see here. I can give you one more example for this, this SOCl2. We can also write like this. Suppose we have here R and H plus, here we are getting SO2Cl2, okay, SO2Cl2. So so I'll give you one example for this SOCl2. Suppose we have here R and H, okay, plus SO2Cl2. So in presence of R2O2, okay, R2O2, 2O2, it will give RCl plus SO2 plus HCl, okay. So again, if we are taking here CH4 and plus SO2Cl2, at that time it will again, if we are taking here R2O2, okay, then it will form what, CH3Cl plus SO2 plus HCl, okay, as you can see here. So what is happening, if you talk, if you see clearly what is happening here, and here you will see that, suppose this is R, O, O and R, okay. So what is happening here, this one is just going here, breaking here, this one is breaking like this, okay. So when it will break, it will form like this, RO and plus OR like this, okay. So after this, when it will form this RO, which one is formed here, it will react with this SOCl2. SOCl2, how we can write, we can write like this, okay, Cl here, one Cl here, and here double bond O, okay. So now this will react with this to form like this, okay, it will react with this to form SO2Cl plus RCl. Okay, I hope you have understood this, right? So now next, in the next step after this, what will happen? This SO2Cl, okay, it will again give what? SO2 plus chlorine free radical here, and this chlorine free radical, okay, will react with this RH to give this R plus HCl, okay, and the last step, this R, it will react with again SO2Cl2 to give RCl, to give what? RCl plus SO2 here and Cl. Okay, I hope you have understood the mechanism, right? How it is it happening, right? Now, so this was all about the preparation of alkene, preparation of haloalkenes with alkyne, okay, ANE. Now we will see first alcohol, after that we will see alkene, okay. First of all we will see alcohol, right, from alcohol. So when we talk about the alcohol, the first process is called by HX, okay, by first processes were by HX, okay. This process is also called what? Group's process or Lucas test, okay. Group's process or Lucas test. So we will see one by one what is happening, what will happen here. So first of all, when we talk about the preparation of haloalkanes or alkyl halide from alcohol, so always remember that alkyl halide are prepared from alcohol by the replacement of OH, okay. This OH will be replaced, OH group, by the replacement of OH group of alcohol by any halogen atom. As you can see, simple reaction is given here. This has been replaced by this X and we are getting RX and H2O, okay. So this replacement of OH group can be done with HX, okay, or phosphorus halide or SOCl2. So always remember this OH, right? This OH is what? This is a weak bed leaving group, okay. And what we can do, one more process is there. If we are converting this bed leaving group into a good leaving group, then also we can conduct the experiment, or sorry, we can form alkene or alkyl halide, okay. If we are converting this OH into this OH, which is a bad leaving group, right? Bad leaving group, we have discussed about leaving group. So if we can convert this bad leaving group into good leaving group, then also at that time also we can conduct the experiment, okay. So first of all we will see by the action of halogen acid, which is ZnCl2, okay. So always remember that ZnCl2, when we see the reactivity, or we can say this is also called Lucas test, okay, or group process. So when we will see the reactivity of alcohol, at that time 3 degree will be more reactive than 2 degree than 1 degree, okay. When we see the reactivity of alcohol, and again when we are seeing the reactivity of this HX, the reactivity of HX will follow this. HI will be more reactive than HBr, okay, then HBr, and then HBr will be more reactive than CHCl. I hope you have understood. This is the reactivity of alcohol and this is the reactivity of what? HX, okay. So one by one we will see how it is happening. So what we can say, we can say like this one will be, this is what, 3 degree alcohol, right? So this one will be more reactive than CHOH, okay, and which is a 2 degree here, and which one will be more reactive than OH here, 1 degree, okay, as you can see like this. So when we will one by one we will see this. So when we talk about this, by the action of halogen acid, this reaction is carried out in presence of dehydrating agent such as ZnCl2 or H2SO4, okay. So what was the, and what we are taking here, the 1:1 ratio of HCl and anhydrous ZnCl2 is called Lucas test, Lucas reagent or Lucas test. This is also called Lucas test or Lucas reagent, okay. And this reaction is also known as Groves process. Always remember that this is very important for your exam. This is also called Groves process. So as we all know that this ZnCl2 is what? It is a Lewis acid, okay, and which coordinate with this ROH. It will coordinate with this ROH as ROH ZnCl2 to make ROH bond weaker. thus increasing the leaving tendency of OH. Well, I will tell you what will happen here. Just this ZnCl2, when we talk about this ZnCl2, this ZnCl2 is what? It is a Lewis acid, okay? It will coordinate with this ROH, okay? It will coordinate with this ROH, and when it will coordinate with this ROH, it will form like this RO, okay? H, okay? ZnCl2. So what basically what it is doing, it is just making the bond of this R and OH bond weaker, okay? And when it become weaker, at that time it can easily break out, right? It can easily leave that, then this OH can easily leave, right, this group, R group, okay? So what is it basically, this ZnCl2, what it is doing, it is just making the R and O bond weaker, and thus increasing the leaving tendency of OH, okay? So as you can see the reaction here, as you can see here, this ROH plus HCl, okay, this ROH plus HCl or concentrated HCl in presence of ZnCl2, it will give RCl plus H2O, okay? And if it is 2 degree, then we can also tell like this CH3 CH2OH plus HCl will give ZnCl2, and it will give CH3 CH2Cl plus H2O, okay? So as I have already told you, the reactivity of halogen acid will be this one. As you can see here, it is also written here Hi, Br and Cl, okay? And when we talk about the reactivity of halogen acid, okay, it will be this one, 3 degree, 2 degree and 1 degree, okay? So I hope you have understood this. And what is the reason for this? This reason is an example of nucleophilic substitution, okay? This reaction is what? It is an example of nucleophilic substitution reaction, okay? Now when we talk about the reason, it will be like this. Suppose we have carbon here, here is OH, okay, and here is suppose D, here is suppose T, and here is H, okay? So if we are supplying here ZnCl2 in presence of HCl, we will get what? We will get like this, okay? C, T, D, okay, D, and here we will get Cl, okay, and here will be H, okay? So this type of reaction is what? This is a type of SN2 reaction, okay? As you can see, the nucleophile, this one, this Cl is attacking from the back side, okay? It's not attacking from here, right? It is going and attacking to the from the back side. I hope we have understood. We have discussed about SN2 reaction, okay? Now if one more example we can see, suppose we have like this, okay? Suppose this is OH, okay, and when we are supplying here ZnCl2, okay, or HCl, we will get two products. One will be like this, okay, one will be like this where Cl will be there, and another may be like this, okay, where we will get like this Cl, okay, sorry, we'll get like this Cl, okay? So this is the product. So one is SN2 product and one is SN1 product. So always remember that here SN1 will dominate SN2, okay? I hope you have understood this, okay? Now next is what? By the action of phosphorus halide. So phosphorus halide, it will always give SN2 type reaction, okay? Always remember that the phosphorus halide will always give SN2 reaction, SN2 reaction type of reaction, okay? And oxygen capturing, some of the oxygen capturing group, this PCl5, PCl3, right? This one PCl5, okay, and PCl3 or PBr3 or SOCl2. These are what? These are just an oxygen capturing group. It used to capture the oxygen, okay? So when we talk about the action, by the action of phosphorus halide, we will see that the alkyl chloride are formed by the action of PCl3 or PCl5 on alcohol, okay? As you can see, ROH plus PCl5 will give RCl plus POCl2 plus HCl. Again 3ROH plus PCl3 will give 3RCl plus H3PO3, right? As you can see, one if you will see closely, okay, when you will see the closely, what will happen here, if suppose we have like this, okay, we have like this, here is hydrogen, okay, OH, okay, if here is OH, so if it will react with PCl5, okay, and the reaction will be SN2, as I have already told you. If the reaction is SN2, then what will be the product? You can guess the product, right? So the product will be this, okay, the product will be this, okay, Cl, right, plus PoCl3, Cl3 plus HCl, okay. I hope you have understood this. Now if you will see the this if we are talking about this, suppose we have this OH, right? So if we are applying here PCl5, okay, so it will convert into like this, C double bond O Cl, okay. Now if again if we have this C H double bond O, again if we are supplying PCl5, so it may change to like this, Cl here, Cl here, or H here, okay. Now one by one we will see this. In case of, as you can see, in case of the propagation of alkyl bromide or iodide, this PCl3 or Pi3, it will required for the reaction is generally produced by the site of action of red phosphorus or on Br2 or I2, okay. As you can see here, 3O plus PBr3 will give 3RBr plus H3PO3, okay. We can see 3R plus OH will give PCl3 plus PCl3 will give 3RI plus H3PO3, as you can see. And this method gives a good yield of 1 degree Rx, but poor 2 degree and 3 degree, okay. And alcohol on heating from alkene, and this method is used in preparation of lower RBR or RI in a lake, okay. We will see what is happening here. I hope you have not understood this. Suppose we have here R and O, and suppose I am writing H here, okay. And if suppose we are using here PCl3, so it has vacant d orbital right here, like, so what will happen, this will go and shift here, okay. So when it is shifting here, it will form like this, R O H, okay, and PCl2, okay. Then whatever the free Cl which is present here, the one Cl has come from here, right, that free Cl will come and attack to this, okay. When it will attack this, it will form like this. Let me draw it in a clear way, okay. Here any empty space is there, let me find the empty space, okay. Here let me draw here, okay. Here suppose we have this, let me understand, let you know how we have to use PCl3 or PBr3, okay. So how we will use it is a very simple. Suppose we have R and OH here, okay, and if we are using here PCl3 here, suppose vacant d orbital, this O will go and attack this, okay. So at that time it will form what, R, okay, O, okay, this here H, and after that here PCl2, okay. So one Cl which is left here, this will go and attack to this hydrogen, okay. So when it will attack to this hydrogen, the product will be like this, R dash O dash P, Cl here, one Cl here, okay, right. And after that again what will happen here, there will be a shift, okay. Again this chlorine, when we are taking this Cl, chlorine free, this will come and attack to this will come and attack to this R, okay, and this will go and shift here, okay. At that time we will get what, we will get the final product like this. We will get the final product R Cl plus PoCl2, okay. I hope you have understood this. So you can easily identify, right. If I will give you one example, suppose I am giving you an example, we have like this, okay, we have like this, and here suppose we have OH and here H, okay, and suppose here is CS3 and here H, and if we are giving here PCl3, if the reaction is SN2, what will be the product? Can you guess the product? Right, so we can guess the product easily, right. It will be this, the OH will here, the OH in place of OH, this hydrogen will come and Cl will be here, because it is an SN2, it will backside attack will be there, CS3 here and H is here, okay, right. I hope you have understood this. Now if you see the general reaction, if I am talking about a very general reaction, suppose we have r o h here, one, again r o h here, again we have r o and h here, okay. And if we are giving here PCl3, okay, PCl3, then what will happen? Always remember that this portion will combine with each other, okay, and the product what we will get, the product will be what? Product will be 3RCl plus H3PO3, right? So in this way we can do this, right? So if we will see now, next is what, I hope you have understood this. Now next is what? Darjan's method, okay. So when we talk about the Darjan's method, so Darjan's method is what? In the Darjan's method, we are using this SOCl2, so thionyl chloride. This thionyl chloride SOCl2 react with the straight chain primary alcohol without replacement in the presence or absence of pyridine. Okay, yeah, one time we will see in the presence of pyridine, and again next time we will see in the absence of pyridine. Okay, so in the presence of, when we talk about with the presence of this as SOCl2, when there is a presence of pyridine, so in the presence of pyridine the reaction will be SNI, okay, and there will be a retention in configuration, okay, and the SCl does not dissociate and SCl will not dissociate, okay. I hope you are understanding this, okay. This alkyl chloride is produced by reflexing alcohol with SOCl2 in presence of pyridine, okay. There will be two types, either in the presence of pyridine or in the absence of pyridine, okay. So in the absence of pyridine, when you will see when by, if you are taking number A, suppose SO sorry suppose SOCl2, okay, and if no pyridine is there, if pyridine is not there, okay, pyridine is not there, pyridine, okay, if there is no pyridine, so what will happen? So if there is no pyridine at that time, the reaction will be SNI, okay, and the reaction will be SNI, okay, SNI. I hope you have we have discussed about this. And number two, there will be a retention in retention, okay, retention in configuration, there will be a retention in configuration, okay. And the third will be SCl will not dissociate, okay, the SCl does not dissociate, okay. These are the three criteria when there will be no pyridine, okay. So here it is given for when there will be a pyridine, when there will be no pyridine, okay. So how will be the reaction will proceed? You can see like this. Suppose we have here R, there's OH, okay, like this here, one lone pair. So if it is reacting with this SOCl2, okay, when it is reacting with SOCl2, it will produce what? It will produce like this, R, there's O plus here, okay, and here hydrogen, okay, and after that again S, here again chlorine, okay, and here double bond O, okay. It will form like this. And after that what will happen? This is the extra chlorine, as I have already told you, the extra chlorine, since Cl2 was there, right, SOCl2 was there, so the extra chlorine will react with this hydrogen, okay, and it will form a product, this one, it will form a product like this, R dash O dash S double bond O, okay, and here Cl, here again SCl, okay. And again what will happen? This Cl will go and attack to this, and when it will attack to this, there will be a shift in the bond here, and the final product we will get what? RCl plus SO2, as which we have discussed, right. Now how we can say that there is a retention in property, okay, retention and configuration. So for retention and configuration, I have given you one example, right. So this type of reaction is what? The reaction which we have seen, that is substitution reaction internally, okay. Internally, this I have seen, right, there is a shift, so there is a substitution reaction, as you can see, there is a shift in the, as you can see, there's a shift, right? This this will go and attack to this, and after that this is going here. So this is what, this is a substitution reaction internally. Okay, substitution reaction is taking place internally. Now next is what we have told, this SOCl2, when pyridine is not there, then it will be what, there will be a retention in configuration. So for retention in configuration, we can give you one example. Suppose we have this, okay, suppose we have like this, okay, and this one is like this. Suppose we have OH here, okay. So when we are applying here SOCl2, say SOCl2, so what will be the product here? Product will be like this, okay. There is a retention in property, as you can see, the place where OH is there, Cl is also in the same place, okay. So this type of reaction is called what, retention in property, okay. Now here next thing, the HCl does not dissociate, as I have already told you, HCl will not dissociate, and the entropy of the reaction will increase, okay. As you can see here, when we talk about the entropy of the reaction, suppose we have ROH, okay, plus SOCl2, Cl2, so it will form what, RCl, okay. After that plus it will form what, HCl, and plus SO2, right. So this HCl and SO2 is what, it is a gas, right, and this RCl is what, it is just a liquid, right. So here you can say the del Ng will be greater than O, okay, and greater than 0, and del S will be, again it will be greater than 0. So what we can say, their entropy is increasing, okay. So in this way, when we don't have pyridine in the reaction, so at that time the reaction will be SN1 SNI, okay, and there will be a retention in configuration, as you have seen, and HCl does not dissociate, okay. So now when there will be a presence of pyridine, the method which is given here, when there will be a presence of pyridine, okay, so at that time the reaction will be SN2, okay. Always remember that the reaction will be SN2. There will be an inversion, not retention, okay. There will be a inversion in property, okay. So we will see what is happening here, as you can see, and there one example is given here only, one example is only given, so I will give you one example here. Suppose, first of all, what is happening, this SOCl2, which is an which will react with this HCl acid, okay, and the base, which is a pyridine, okay. So it will give I will give you one example here. You can see, suppose what will happen, first of all, there will be this reaction will be SN2 type, okay, and there will be an inversion, okay. And this SOCl2, what it will do, it will convert this HCl, which is an acid, right, this is an acid, it will convert this acid and this pyridine, this is pyridine, okay, this is what, this is a pyridine, right. So this pyridine into this, okay, it will convert this pyridine into this, okay, it will convert this pyridine into like this, okay. Here N positive, okay, N positive plus Cl negative. So this is these are the three methods which we will proceed when it is pyridine is present, okay. So now, as you can see, let me find some empty space right here, we will see the example, okay. So when there is a presence of pyridine, suppose we have what, here is R O S, suppose Cl, and here double bond O, okay, and suppose there is Cl here. So what will happen, this Cl will attack to this R, okay, and there will be shift in this O, okay, and this Cl will come out, okay. So this reaction is what, this is what, SN2 reaction, right. So what we will get, ClR, okay, plus SO2, okay, and what we will get, Cl negative will come out, okay. So you can see here this type of reaction is proceeding. Now when we talk about the inversion, so what will be the inversion, how the inversion is taking place. So inversion will be like this. Suppose, first of all, it was like this. I hope you know the meaning of this, right, this dotted one. I hope you know the meaning, right. So suppose there is a chlorine is here, or we can show like this. Suppose we have there here alcohol, and if it is like this, if it is shaded, means it is above the plane, right, it is above the plane here. So if we are giving here SOCl2, okay, so and so if there we are giving here SOCl2, and here also let me do it clearly. It is very, suppose we have alcohol here, okay. This is shaded means what? It is above the plane, right? OH here, okay. So suppose if we are giving here SOCl2, SOCl2, here also if we are giving here SOCl2, so if there will be an inversion, if there will be retention in property, because I have already told you that here in with the presence of pyridine there will be not be a retention in property, okay. So it will not form like this, it will not form like this, okay. It will not form, it will not form like this, okay. It will form like this because there is an inversion, right? As I have already told you, there is an inversion, so it will form like this, okay. Cl, this will be the product. It will not be like this, not it will not produce this one. I hope you have understood this, right? Now after this we will suppose, let me see here. Yes, everything is given here. Now when we see the use of red phosphorus or red P or I2, at that time also we can see if it is given here. Let me check, okay, wait. Okay, leave after this, okay. In the next class we will see Hunds-Docker reaction, okay. After that, I hope you today's class you have understood. So leave after this Darzin's method. In the next class we will see Hunds-Docker reaction and all, right. Till that, thank you.